this is the rule for the mapping. By equation of a line, say y is equal to 2x. That's equation of a line, a straight line. All right, so let's move on. So this is a rule. Inverse of a rule, or inverse of equation of a line. So inverse of a rule is simply inverse is just make x the subject, because here we have y as a subject, so just make x the subject and reciprocate the what? Reciprocate the terms, reciprocate the variables. So y is equal to 2x. Let's see how it works. Y is equal to 2x. Good. Y is equal to 2x. So if I want the inverse of this, I want to make x the subject. Divide both sides by 2. 2 cancels 2. So we end up getting what? Y. It can also be written out. You just turn it. You just bring the x here. So x is equal to what? Y over 2. X is equal to y over 2. If you have x is equal to y over 2, if I have x is equal to y over 2, and I want to write it normally, as I said, you just reciprocate, you change the terms. So this one, you write y for it equal to, here, you just write what? X for it over 2. This is the inverse of y is equal to 2x. Inverse is a fraction. It's just reciprocating the term. Then change the variables. This is how simple it is. Inverse. All right, now let's move on to the next one. We are going to look at the three methods you can identify, just like I told you earlier. You can identify the rule for a mapping by observation, by inspection, and this is what you and I have been doing for this while. The next one is equation of a line method, then exponential equation. So let's look at equation of a line method. The equation of a line method is so simple. It works if and only if there's a common difference between the terms. So to go that, let's go back to some of them. Let's go back to some of the mapping, the previous one that we dealt with. It will work if there's a common difference between the codomain. Yes, if there's a common difference between the codomain. Look at it. What's the common difference? Means subtraction. So 12 minus 8 is 4. 8 minus 4 is 4. So there's a common difference. Let's look at the down one. The one down. Good. That one, it says what? 6 minus 4 is 2. 4 minus 2 is 2. So there's a common difference. Good. Common means it must be everywhere. When we come to this, let's look at this one too. Let's look at this example up here. So the equation of a line method works if and only if and only if there's a common difference between them. Now let's look at this one. 9 minus 4 is 3. Is it 3? It's 5, sorry. 9 minus 4 is 3. 4 minus is 5, sorry. Sorry for me, forgive me. 9 minus 4 is 5. 4 minus 1 is 3. 1 minus 0 is 1. This one, you cannot apply equation of a line method. Either you use observation or exponential. Good. We look at the exponential, whether this one also work for exponential, or we have to restrict ourselves to the observation or inspection. So, like I said, it works. The equation of a line method works if and only if the intervals between the codomain are equal. Now, equation of a line must appear like this. Equation of a line must appear this way. Y is equal to mx plus c, ms plus c, or you can say y is equal to ax plus b. It could be either of them. It depends on the books. They can use any variables at all. So if you write it, you indicate to the examiner why a or m in this case means the gradient or slope. You know gradient or slope from social studies or from science. Slope, the slope of the line. It can be slope, steep slope, or gentle slope. So if a hill, if you want to know the slope of a hill, that's how steep it is. Is it steep? How steep is it? Steep slope or steep hill or gentle hill? For a steep hill, it is difficult to climb, but for gentle hill, so easy, almost flat, so you can easily go. So that's the slope. So when you draw equation of a line, the steepness of it is determined by its gradient over here. The higher that number, the gradient, the steeper the curve or the straight line, and vice versa. So that's it. The B here or the C here is the constant. That is where the straight line cuts the x-axis. Sorry, the y-axis. So this y goes. So let's look at this simple. This. If I have this, and this is my straight line curve, it's like this, right? Where the curve cuts the x-axis here. Sorry, the y-axis. Sorry for that. Sorry for that. I'm so sorry. Where I've painted green. Where it cuts it, that is the y-intercept. So that place could be, let's say negative 2. Good. So the y-intercept is -2. So her examiner draws the graph for you or gives you the graph and say find the equation of a line. After getting the gradient, all you have to do is just put the -2 there. If I have another curve like this, if I have another curve, let's assume that this is 1, this is positive, so this is 1. Yes, that place is 1. So the y-intercept is 1 for that matter here. It's positive 1 because it's above the origin. This is the positive 1. That's the y-intercept. So where the curve cuts the y-axis is the intercept. Simple. Now, like I said, the gradient of the curve. When the curve faces the right side, it's heading towards the right side. You see the arrow pointing? It's heading towards the right, from left, heading towards the right. That means the gradient is positive. The gradient is positive, it's a positive curve. And when it faces left, sorry, good, like this one is heading towards the left side. Therefore, the gradient will be negative. When you calculate, you surely get negative. This is what you must observe. So you can guess how the answer will look like when the curve is given to you. You get it? Good. Now, this is the picture. So right side, positive, left side, negative. Is that okay here? So simple. And where the curve cuts the y-axis is the y-intercept. Good. So take note of that. Now, let's look at how we can generate or calculate the gradient of the curve. If I have this, and this is the curve, right? To get the gradient of the curve is determined by the length of the y-axis compared with or in relationship with that of the x-axis. Yes, they determine whether it is slopy or gentle, or whether it is steepy or gentle. So you can consider this one is average. Right. Now, how do you determine that? So it is changing y. So gradient, let me represent my gradient here in this case by m. Gradient is represented by m. Change in the y divided by change in the x line. That's all. So in that case, if I want y-axis, this one will be y2 and this side will be y1 because upper is bigger. So y2 minus y1 gives you the change. Change means minus. So between them, so that the value will also be given to you. So the examiner can say this place is 10. If it's given to you as 10, you don't have to find the difference between y2 and y1 anymore. It is given to you. but it's not given to you what there are something that this is 0 and this point is 10. So if you want between this and that, you don't say 0 minus 10. 0 minus 10. 0 minus 10 is wrong. You get negative. To determine the length of a line is the upper minus lower level, or the end point minus the starting point. So it is rather 10 minus what? 0. So from the end to the beginning, you start the difference. That gives you positive. So that's why we say y2 minus y1. Then the x-axis, this will be x1. Do you agree? And this will be x2. I hope you agree with that. Y here is x2 and here is x1. I believe you agree with me. What the matter? Let me use a different color to indicate that for you quickly. Okay, so here will be x2 and this will be x1. Why? If you're heading towards the right side, x is bigger, positive. You're heading towards the positive, right side of a x-axis is bigger. The left side is lower. Therefore, that's how it should be. The left side should be the smaller one. So you get your x2 minus x1. So at the end